Hello students, we're going to do 8.3.8 practice problems. But before I do, I want to give you a review from our lesson. In Unit 8.3.8, you're starting to learn how the graph of a line can move up or down and what the equation looks like when the line moves up or down. So first, a quick review of the lesson from 8.3.8 lesson, which you finished last. If you didn't do the lesson, you better go back and do that, but I'm going to give a quick review. Here, you see the equation of a line. Right now, the line is at the intercept, the y-intercept equal to 0. So y equals 0. Now I'm going to move the intercept up to y equals 2. Look what happens to the equation of the line. Maybe you already know because you did your previous lesson. If you understood the previous lesson, then this is no surprise. Now, when y equals 2, this number here goes up to 2. Great, you got it. So what we learned so far in this unit, in Unit 3, we started with an equation, y equals some rate constant k times x. So for example, if our rate was, say, 3, then y equals 3 times whatever x is. In that case, if x equals 1, y equals 3. If x equals 2, y equals 6. If x equals 10, y equals 30. You have a lot of experience by now plugging numbers into this kind of equation and making a table of values and then graphing them. After learning equations of this form, we learned equations of another form, which is just a little different. Y equals some proportional constant times x plus some b or some value that you start out with. That is some value that you started out with. Let's say you started out with b equals $30 in your bank account and you get a new job, you make $5 an hour, maybe walking your neighbor's dog, I'm not sure. $5 an hour is your K, 5 times X hours worked, plus you already have $30 in your bank account, and Y equals your total savings. You've seen equations like this before, but I'm just going to review quickly with another table. So when X equals 1 hour of work, you have $35. Oh, I'm sorry, I wrote that in the wrong spot. When x equals 1 hour of work, you have y equals $35. X equals 1, so you plug in 1. 1 times 5 is 5, plus $30, so y equals $35. When x equals, say, 5 hours of work, then you have 5 times 5, $25 earned, plus your original $30, so you would have $55. You are very familiar with equations of this form. Well, now, what if we don't tell you the situation anymore and we just look at the graphs of the lines? So that's what we broke into with this new unit. We are looking at lines with the form y equals m times x plus some constant b. So m, before we called this k, the proportional constant, but we just changed it to m because now we're just going to call that the slope of the line without thinking about what the situation is. Just look at the graph without worrying about the situation. That way we can learn more about what these numbers do. So please remember that previously we used k to represent a constant rate, But now we're just going to call that m, and it's the slope of the line. Okay, then in your last lesson, you watched what happens as you move this point up and down. I'm going to do that one more time. Let's move it up to 4. 4. Did you see what happens to the equation? Exactly what you would expect. The y-intercept changes. Let me make sure everybody remembers this b is the vertical intercept or the y-intercept. I'll just call it y-intercept for short, y-intercept. And I'll draw that on the graph to make sure everybody knows what it is. Right here, the vertical axis, the y-axis. You can call it the vertical axis or the y-axis. And where your line crosses that axis, that is called the y-intercept. So let me draw the line. Here is the line in our graph. And the y-intercept, or the vertical intercept, is exactly where they cross. In this case, the vertical intercept equals 4. Oops, my computer pen doesn't work perfectly. That's supposed to be a 4. B equals 4. Okay, let me move this line again. And I'd like you to guess what's going to happen to the equation. So right now we are at y equals 1/2 x plus 4. That means our slope is 1/2. Now the slope is going to stay the same. I'm just going to move the line up or down. That is a translation, like you learned in Unit 8.1, we learned translations. So let's say that I'm going to translate this line up 2 more units. Then everywhere on the line moves up 2 more units. Where do you expect the y-intercept to be? If everywhere on this line moves up 2 more units, then I predict this 4 is going to move up to this 6. And the equation of the line will be y equals, the slope stays the same, 1/2 x plus, we're going 2 more units up, so we're going from 4 to 6, so b is going to be equal to 6. Okay, let's do that and let this computer template tell us what the equation will be. That's right. I put it there on the 6. The equation of the line stays the same, except for the y-intercept equals 6 now. Okay, let's go to our assignment. You learned all that already anyhow. I just wanted to give you a review. Now we're doing the homework for Lesson 8. This is 8th grade math, Unit 3, Lesson 8, practice problems. Okay, number 1. Select all equations that have graphs with the same y-intercept. Here are the equations that we're looking at. And don't forget to have the equation of a line written somewhere in your notes next to you. Y equals mx plus b. We're using this standard form of an equation. Don't forget m equals slope. That's the slope of the line. B equals, don't forget, B equals y-intercept. I'm just going to write y-int to save some writing. Select all equations that have a graph with the same y-intercept. Okay, here is the y-intercept in these equations. Circle them all. Now we're looking for graphs that have the same y-intercept. Aha! This intercept is negative 8. 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 Those are all the same. This intercept is positive 8. Positive 8 right there. But there isn't another equation with an intercept of positive 8, so it is not the same. This intercept is negative 9, but it is not the same as any other. So all of these, if I were to graph them, let me just sketch a graph really quickly. We would have 3x with a y-intercept of negative 8. Negative 8 is down here. 3x, 3 is a positive slope. That means y increases by 3 every time x increases by 1. That's a kind of a steep line there. Now let me graph the next one. This one here. Y equals 5x minus 8. So 5, the slope is 5. That's even steeper, but it has the same y-intercept of negative 8. There. Okay, and then this one, y equals 2x minus 8. So that has the same intercept, but the slope is 2, so it's not as steep. And then the last line has a slope of 1/3 and the y-intercept of negative 8. So 1/3, not too steep right there. Okay? I hope that you already knew that, and I hope that I explained too much. I hope that I explained too much because you've already learned it. Okay, so let's go ahead and select all equations that have graphs with the same y-intercept. It'll be the top one has a negative 8 intercept. D, E, and F have negative 8 intercepts. Number 2. Let's keep going now. Number 2. Number 2 says create a graph showing the equations y equals 1/4 x and y equals 1/4 x minus 5. Explain how the graphs are the same and how they are different. Okay, so we're going to graph 2 lines on this grid. So first, why don't I just sketch an intercept, my axes here. I'll just sketch, and you should do this too. Please sketch your axes on your grid. And I like to be really thorough when I teach things. That's why my videos are too long, is because I'm talking too much, but I hope that if you missed something, I can repeat it and you can learn it as you go if you missed something in a previous lesson. So please be patient while I explain way too much. So there's the y-axis, it's going up and down, and the x-axis is going to the right. And it says create a graph showing the equations. Now, I'm very good at math, so I can just look at this equation and I can graph it instantly. But in case you missed a couple of lessons, let me just catch you up. You should start by making a table of x and y. Then plots, just decide on some points. How about when x equals -1, when x equals 0, when x equals 1, when x equals 5. I'll do one more. X equals -10. There's one more. Okay, so if x equals -10, you're going to substitute in -10 here. 1/4 times -10 is -10/4, which is -2.5. When x equals -1, which is my next value in the table, hold on a second. I think my table is a little bit crammed together. Let me move that down. Now, if x equals -1, substitute in -1. -1 times 1/4 is -1/4. Now, substitute in, how about 0? X equals 0? Well, then y is equal to 0. And how about if x equals 5? I'm just going to jump ahead. X equals 5, then it'll be 5/4. How about when x equals 16? Then if x equals 16, 16 divided by 4 is 4. Let's plot these points. When x equals negative 10, that's here, x equals negative 10, y is negative 2.5. 1, 2.5. Ooh, it's a little hard to draw with my computer pen. When x equals negative 1, y equals 1/4. So that's just right about here, I guess. Very hard to draw that accurately. And then 0, 0 is on the graph. And when x equals 5, y equals 5/4. Just right about up there, right there at the line. Not quite the line. When x equals 16, y equals 4. So here's 10, 15, 16, 1, 2, 3, 4. Right there. And now I can draw a line. Now, before I plotted these points, I said I'm very good at math. It would be easy for me to do this without making a table. Let me show you how. I'm going to erase everything I've done, and this is how you should be able to do it by now. By now, you should just recognize that this is the slope of the line. This is the slope, and the slope means rise over run, and you've heard it 1,000 times. Now I'll show you how to use it. I didn't get that right on there. Try that again. Okay, here's my y-axis, my vertical axis, and my horizontal axis here. Okay, let me show you how to just plot this equation just by looking at it. So there is no y-intercept. It is just 1/4 x. So that automatically tells me that the intercept, the vertical y-intercept, is at 0. And now I'll go up 1 over 4. Rise up 1, and then count 4 over. 1, 2, 3, 4. Oops, very hard with my computer pen. Up 1, and then go over 4. 1, 2, 3, 4. Up 1, and 1, 2, 3, 4 over 4. Just like that. I could even go the other direction, but I'd have to think backwards. Down 1, and then over 4 in the negative direction. Great. Now you got it. Then draw a line connecting your points. See, I can just look at this equation, and I know it starts at 0, 0, and the slope is 1/4, so I can just count that as I go. Now, let's look at the next equation. Here is the rise over run, the slope, but it has a y-intercept. You've already seen what the y-intercept does. It moves the line up or down. The y-intercept is -5. The negative matters. Here is, let me change colors. Find -5, y equals -5 on your graph, and put your first dot right there. Now, you're starting from this point. Remember, the y-intercept is like a starting point. You have the same slope as before. So you can just kind of figure out that it's going to have a slope like that. It's the same slope as before, but starting lower. Let's go ahead and count out the slope in case you don't believe me. Okay, up 1 over 4. 1, 2, 3, 4. Put your point there. Up 1 over 4. 1, 2, 3, 4. Up 1 and then over 4. 1, 2, 3, 4. And so on and so on and so on. The slope is going to be the same, but the line has moved down. The question asks you to explain how the graphs are the same and how they are different. So get your pencils ready. I want you to give me a good explanation. And I'm going to help you with that in case you're not really that good at thinking how you want to say things. Let me just give you my ideas. In the first line, should I say the first line? In the first equation, the y-intercept is 0. In the second equation, the y-intercept is negative 5. The slope is equal to 1/4 in both equations. They both have a slope of 1/4. But one line is lower than the other. Okay, there's a very good explanation. I want you to pause the video and look at your notes and answer the questions thoroughly. You need complete answers or else there's no credit. Okay, good job. I'm going to keep on going. Let's work a problem. A cable company charges $70 per month for cable services to existing customers. A. Find a linear equation representing the relationship between X, the number of months of service, and Y, the total amount paid in dollars by an existing customer. B. For new customers, there is an additional one-time $100 service fee. Repeat the previous problem for new customers. And C, when the two equations are graphed in the coordinate plane, how are they related to each other geometrically? Okay, let's work this problem. A cable company charges $70 per month for cable service to existing customers. Okay, got it? So that's already going to tell us a rate in the problem. Some rate of $70 per month. Find a linear equation representing the relationship between X, the number of months of service, and Y, the total amount paid in dollars by an existing customer. So this is not the monthly amount paid, this is the total amount paid. Like if you've had your service for 10 months, how much have you paid altogether? Okay, for A, and you guys should be writing this on your paper or in your notes, but you'll need to turn this in. My equation for the total amount paid and Y equals total amount paid, well, that equals the monthly cost times the number of months I've had service, which we'll call X. X, the number of months of service. So $70 a month times how many months you've had your plan is the total amount paid. Now, B. For new customers, there is an additional one-time $100 service fee. Repeat the previous problem for new customers. Okay, we're going to make another graph, but this one is for new customers. New customers start with a $100 fee. I'm going to put that right here, but it's actually at the end. They start with a $100 fee, and the total amount they have paid is equal to the monthly rate of $70 a month times the number of months they've had service plus the $100 fee. So there's my answer for B. Make sure that you understand those equations. Problem C. When the two equations are graphed in the coordinate plane, how are they related to each other? Okay, let me just sketch a coordinate plane. And you should sketch this too. You're going to need this on your paper. You're going to need to answer A, B, and C. Okay, looking at A, the graph of the line is y equals 70x. We already know that if x equals 0, y equals 0. So go ahead and plot your first point there at 0. Now, if x equals 1, that would be 1 times 70, then y equals 70. And that makes sense. After 1 month, You've paid $70. So just imagine this is 70 and this is 1. Just imagine. And then when x equals 2, 2 times 70 is going to be $140. So just imagine that's about right there. This is 1 month. This is 2 months. And then when x equals 3, after 3 months, 3 times 70 is $210. So just sketch that somewhere on your paper. Not somewhere, I mean try to make it look good. So here's my graph. It goes up to 70. This is y equals 70. There we go. Y equals 140. Y equals 210. This is x equals 1, x equals 2, x equals 3. Okay, now we have to sketch the second equation, B. This is where customers start out with a $100 fee. I bet they're not happy about that. Before I sketch that, let me draw the line for these points right about there. If I drew it correctly, they're all on a straight line, but this is just a sketch, so it's okay if I'm a little off, but it should mostly make sense. Your graph needs to make sense. So they're starting with a $100 fee. Well, if this is 70 on my graph and this is 110, then I guess 100 is going to be a little less than 110. So that's my first point. When x equals 0, y equals $100. How about when x equals 1, after 1 month, then it's 70 plus 100, y equals $170. And when x equals 2, then y equals 140 plus 100, 240, and so on and so on. Let me graph the points. When x equals 1, y equals 170. I guess that's going to be right about halfway here. 110, 30, 40, 50, 60, 70, something like that. And then at 2 months, it's 240, so that's going to be like, I don't know, right here. It's just a sketch. Okay, and then I'm going to draw that line. Something like that. Something like that. Okay, how are these two lines, how are they related to each other geometrically? Well, you had a whole long 2 units on geometry before we even got to this point. So what did you learn in geometry? You learned about translations. Translations is where every point on the figure moves in the same direction by the same amount. So this point on the figure would move by the same amount in the same direction. This point on the figure, same amount, same direction. This point on the figure moves by the same amount in the same direction. So you can see how these are related geometrically. Let me type it in. The second equation is translated up by 100 units. That's right, the purple line is translated up by 100 units. And how do I know it's 100 units? That's what our equation says, plus 100. Everywhere on the line is plus 100. Okay, in your assignment, when you turn this into me, I want to see the equation for A, the equation for B, and I want to see your graph for C. You must have it nice and neat, and you must explain how they are related to each other geometrically. You cannot skip parts of the question. Your answers must be complete. Let me keep going. All right. The directions say, match each graph to a situation and write the equation for the line. Okay, let's do it. Starting with number 1, And this is going to be a little hard to go up and down, but bear with me. Number 1 says, the graph represents the perimeter y in units for an equilateral triangle with side length of x units. The slope of the line is 3. Okay. So then y equals, if we just quickly make an equation, y equals 3x. And that makes sense. It says x is the side length of an equilateral triangle. So this length is x, and this length is x, and this length is x. And y is the perimeter of the triangle. And the perimeter is going to be x plus x plus x. So that's 3 x's. This equation makes sense. Now let's find the graph that matches that. It should have a slope of 3 and a y-intercept of 0. Because when x equals 0, then we have no triangle length, therefore no perimeter. Okay, look at your graphs and figure out which one fits. Now A and B, they both have a y-intercept. That doesn't make sense. If the length of the triangle were 0, then we know we have 0 perimeter. But this would mean if the length of the triangle edge were 0, our perimeter would already be 8. So you see, a y-intercept doesn't make sense in this situation. We're probably going to choose C or D. Let's find the graph that has the slope of 3. Now this graph, the scale is 1 unit per tick mark. So the slope is, let me find 2 points that are easy to read, right here and here. Looks like the slope goes up by 5 and over 4. It is not equal to 3. Let's find the slope on this. I look for 2 points that are easy to read. How about this point and the starting point? So the rise is 15 units up, and the run is 5 units over. You must simplify that, and you get a slope of 3. Ding, 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 ding. Okay, then. Situation 1 matches graph C. You can just put C on your paper there, and we need to write an equation for graph C. Well, I kind of did that automatically. Maybe I'm a little bit too fast. I did that automatically, though. The perimeter of the triangle, we're calling y, equals 3 times the side length, x. Ding! Okay, let me change colors, and then I'll read the next situation. Number 2. The amount of money y, oopsie, when I move it up, I'm going to lose everything I wrote. You know what? I think that's okay because you already have it in your notes. Number 2, the amount of money y in a cash box after X tickets are purchased for carnival games. The slope of the line is 1/4. Okay, did you get that? Y equals money in the cash box. And X equals the tickets sold, and the slope of the line is 1/4. Can you find the graph? It didn't say anything about a y-intercept, so I guess the cash box has nothing in it when they start. Uh-oh, I don't know why I put a 4 there. That should be an X. I'm pausing so you can go ahead and try it yourself. Okay, well, we already calculated this slope, and we got 5/4, so that's not our graph. They didn't say anything about money in the cash box before they started. They didn't say anything about a y-intercept. But maybe we have to look at these graphs. Maybe there was money in the cash box, and we're going to find out about that by the graph. Okay, let me take a slope here. This looks like a low slope. It starts at y equals 8, x equals 0, y equals 8. And here's another point that's easy to read right here. Y equals 9. I'm going to draw the coordinates of this point right here. X equals 4, y equals 9. Okay, now we can find the slope of the line from those 2 points, and I'm going to draw that slope triangle to help you visualize it. I just drew it really lightly there. We can see a rise of 1. And a run of 4 units. So that's it. The slope from this point to the other point is 1/4. From here to here, rise is 1 and run is 4. That has the slope we're looking for. So that must be it. None of the other graphs have a slope of 1/4. So for 2, that is graph A. Now let's write an equation for graph A. It is y, the money in the cash box, equals 1/4 times the number of tickets sold plus there is a y-intercept. It starts at $8 in the cash box. We know that now. They didn't tell us that, but we can figure that out by the graph. It starts at $8 in the cash box. Okay, let's keep going. I'm going to erase that and go on to the next one. Number 3, the situation says, the number of chapters read, y, after x days. The slope of the line is 5/4. Oh, this is too easy. We've already found this one. Didn't we find that this slope was 5/4? It goes up 5 and over 4 right there. Let me double check the other graphs. Was there another graph with a slope of 5/4? I don't think so. Let me check this one. This graph goes up 2 and over 1. Up 2 and over 1, up 2. So this graph's slope is 2 over 1. Okay, I got it. So back to number 3, the number of chapters read, y, after x days, the slope of the line is 5/4. That is graph D. Put a D there. And then let's make an equation for the line in graph D. Well, the number of chapters read equals 5/4 x. And this means that the person reads 5/4 of a chapter a day. Or you could think of it this way. Every 4 days, they read 5 chapters. Every 4 days, this person reads 5 chapters. And they started with 0 chapters read. So the y-intercept is +0. But you don't have to write the +0. That's just assumed. Okay, the last situation, number 4. The graph shows the cost in dollars of a muffin delivery and the number of muffins X ordered. The slope of the line is 2. Okay, have you looked at the graphs? We're looking for a graph with a slope of 2, and we had already found it because I checked the slopes from the beginning. Let's check again. From here to here, what is the slope of the line? Well, the rise goes 5, 6, 7. From 3 to 7, the rise is from 3 to 7, and the run is from x equals 0 to x equals 2. So the slope of the line is a rise of 4 units and a run of 2 units. 4 over 2, if you simplify that, it is 2. So for number 4, the situation is graph B. It looks like there is a starting cost for this muffin delivery. The starting cost is $3. I can see that because when X equals 0 muffins ordered, Y already costs $3. If you order 2 muffins, then it's going to be $8. Oh, I'm sorry, $7. If you order 5 muffins, it's going to cost you, let me count it, $11, $12, $13. The equation for this line is Y, the cost of your delivery, equals $2 per muffin times X number of muffins ordered plus a delivery fee of $3. We can see all of that from the graph. Okay, now you have written your 4 equations and matched what situation is described by what graph. Let's keep going. Number 5. A mountain road is 5 miles long and gains elevation at a constant rate. After 2 miles, the elevation is 5,500 feet above sea level. After 4 miles, the elevation is 6,200 feet above sea level. Ooh, I can already tell we need a rate. Question A. Find the elevation of the road at the point where the road begins. B. Describe where you would see the point in part A on a graph where Y represents the elevation in feet and X represents the distance along the road in miles. Okay, well, I'm pretty good at math, but even I need to make a table and organize my information. The mountain road is 5 miles long. It gains elevation at a constant rate. After 2 miles, the elevation is 5,500 feet above sea level. Hold on. I'm going to call X the distance on the road. So it starts at 0 miles because it's 5 miles long. And then we're going to have the first mile, second mile, third mile, fourth mile, fifth mile, something like that. They tell me that after 2 miles, the elevation is 5,500 feet. They tell me that after 4 miles, the elevation is 6,200 feet. And now they ask me, what is the elevation of the road at the point where the road begins? Here. Aha. Well, if from mile 2 to mile 4, it gains 700 feet in elevation. Did you see that? From mile 2 to mile 4, we have an elevation gain of plus 700 feet. So I can use this information to make a ratio. The change from 2 to 4 is 2 miles. In 2 miles, the elevation gained 700 feet. Go ahead and make a ratio. That was a 700-foot gain in 2 miles. And if I simplify that, I find that the road's elevation is increasing at a rate of 350 feet per mile. So now, what was the elevation at the beginning of the road where X equals 0? We need to subtract 300 feet and then subtract 350 feet. Subtract 350 feet twice. So our answer is going to be, at mile 2, it's 5,500 feet in elevation minus 2 miles ago times 350 feet of elevation change per mile. So that's 550 minus 700. And the answer is 4,800 feet at the beginning of the road. 4,800 feet of elevation at the beginning of the road. Okay, go ahead and answer number 1 with a sentence and show your math on your paper. I don't want you to just copy me. I'm checking that you really wrote it all down and followed along. Now let's look at B. Describe where you would see the point in part A, point A, on a graph where y represents the elevation in feet. I'm just going to sketch that. Anyway, I'm going to sketch it. Y equals the elevation in feet. So I'm just going to put y is feet. X represents the distance along the road, okay, in miles. So X is miles. Okay, where would you see the elevation of the road at the point where the road begins? Well, that is where x equals 0. That is the point where the road begins, x equals 0. And at the point x equals 0, the road already has 4,800 feet of elevation. That's going to be our y-intercept. You will see that point from situation A, from A. You're going to see that point right here on the y-intercept. And then our road's elevation increases by 350 feet every mile, like this. So at mile 1, it's going to be 5,150. And at mile 2, it's going to be 5,500. And at mile 3, it's going to be, and so on and so on. Okay, so please answer B. Where would you see the point? You will see that point here, the y-intercept on the graph. That is where x equals 0 and y equals 4,800. Okay, good job, guys. Now, I didn't write the answers for you. You have to write the answers and have it make sense on your paper when you turn it in. Go ahead and pause the video back where I had those written down. And then, good job. You have finished this assignment and you're ready to turn it in. See you later.